All right, folks, this is the third video segment for the solution homework number 15. We just finished problem number 38, and we're going to move to problem number 39. So here's the way it's worded. You're given that cosine of x is 3 and x is in this range, okay? Find sine of x over 2, cosine of x over 2, and tangent of x over 2. The first thing that we notice is that if you have this, x over 2 is between 90 degrees and 45 degrees. And what that means is that your angle x over 2 is in here, right? Between 45 and 90. Okay, that will allow you to pick the appropriate algebraic sign for sine of x over 2 and cosine of x over 2. Okay, let's start here. First of all, cosecant of x is 3. That means 1 over sine of x is 3. And therefore, sine of x is 1/3. Okay, so let's start with finding sine of x over 2. Incidentally, the formula for sine of x over 2, if you look at the formula for sine of x over 2, it looks like this. Sine of x over 2 equal to plus or minus square root of 1 minus cosine of x divided by 2. Notice that I have sine of x but not cosine of x. So what I'm going to do from here, first I'm going to find the cosine of x, and the way we do that is either use the formula. And what do I mean by the formula? Okay, so let's okay, so here is x. This is hypotenuse is 3, the opposite is 1, and therefore this becomes the square root of 9 minus 1, which is square root of 8. Incidentally, how do we check this? When you square this and you square that, you add them, you should get the square root of 3, which is 9, which is correct. So cosine of x that I needed for here is the adjacent, which is root of 8 over 3. Now, we just have to watch out about the sign. Now notice that it says x is between 90 and 180. What that means is that your cosine must be negative. So this actually is not correct. You need a minus sign because things like this you have to write on the quiz or the test. Because x is between 180 and 90, cosine of x is negative. Therefore, cosine of x is actually minus root 8 over 3. Okay, so we have sine of x over 2 equal to plus or minus square root of 1 minus cosine of x, we said negative, minus root 8 over 3, okay, divided by 2. So this is plus or minus square root of 1 plus root 8 over 3 divided by 2. Now, the question becomes, which one of these two algebraic signs do you pick? Now, notice that we said that x over 2 is in this shaded region, is in here, right? That means the sign of sin of x over 2 must be positive. Just look at any angle in that shaded red region has sin of it positive. So sine of x over 2 is equal to plus the root of 1 plus root 8 over 3 over 2. Okay? This is because x is between 90 degrees and 45 degrees. Sin must be positive, right? Okay, good. So let's do the cosine now. Cosine of x over 2, look at your formulas. Again, is plus or minus square root. Go and look at my formula. It's 1 plus there's a cosine here. Cosine of x divided by 2. Okay, Now we just worked out cosine of x, correct, with the correct algebraic sign. It came out to be right there. So we just take this thing and stick it in there. So plus or minus square root of 1 plus minus root 8 over 3 divided by 2, correct? Is that what we have? Yes. Now, we have to decide on which one of these you have to pick. Now, just look at where x over 2 is. X over 2 was in this shaded region. The cosine of it, this is quadrant 1, obviously, part of quadrant 1. So cosine is positive, therefore, we write it here, because x over 2 is in quadrant 1, actually, it is in that shaded region. It is in the shown shaded region, part of quadrant 1, shaded region. Cosine of x over 2 is positive. That means cosine of x over 2 is equal to plus square root of 1, and this thing, right? This thing. Minus root of 8 over 3 divided by 2, because there was a minus sign there, right? All right, that takes care of this. Tangent of x over 2. Whatever I get, I better get a positive number because that angle x over 2 is in quadrant 1, shaded red region. It's going to be cosine of sine of x over 2 divided cosine of x over 2. This is sine, right? This is sine. And we worked these out, both of them. This denominator was square root of 1 minus root 8 over 3 divided by 2. And the sine of x over 2, we already did it. It was up here somewhere, right here, right there. You see this? Right there. And it's going to be square root of 1 plus root 8 over 3 over 2. This is a good sign because that expression is positive. It's supposed to be because x over 2 is in x over 2 itself is in quadrant 1 and tangent must be positive. Remember last time I picked up my mistake, and this is why I had an extra 5 minutes at the end of the last video segment trying to find out what went wrong. There was a sign, algebraic sign there. Let's do number 40. Same kind of problem. And number 40 says, same kind of a deal. Tangent of x is equal to 1. X is between 90 and, what is that? 0. Find sine of x over 2, cosine of x over 2, and tangent of x over 2. Okay, now first of all, because x is in this range, x over 2 is less than 45 degrees and bigger than 0, which means sine of x over 2 is positive, cosine of x over 2 is positive, and of course tangent of x over 2 is also positive. So let's start here. Now, remember, to find sine of x over 2, I have to use my half angle formula. Obviously, we don't need a negative sign here. I understand. We're going to clean it up. What did I have there? It's 1 minus cosine of x over 2. Okay, good. So we know that the sign, the algebraic sign is plus because of that. So it's going to be plus square root of 1 minus cosine of x over 2. Okay, it's plus. Now, the question is, what is sine of x and cosine of x? Now, notice that the fact that tangent is 1, this is 1, this is 1, and this is obviously 2. Obviously, this angle is 45 degrees. The moral of the story is that cosine of x is root 2 over 2, and sine of x, if I need it, is root 2 over 2. I don't need sine of x, but this is what I need. So sine of x over 2 is equal to plus square root 1 minus root 2 over 2 divided by 2. That takes care of this. And by the same token, cosine of x over 2 is plus, remember I said that these are both positive, square root of 1 plus root 2 over 2 divided by 2. And of course, tangent of x over 2 is sine of x over 2 over cosine of x over 2. And these values are, well, I can do it like this. I can do it like that. There's no problem. 1 minus root 2 over 2 divided by square root of 1 plus root 2 over 2. But the alternative is to use the formula tangent x over 2 directly like this. Remember, 1 minus cosine of x divided by sine of x, or sine of x divided by 1 plus cosine of x. Now notice that when you use these values, you put this and you put that. They don't look exactly like that, but if you do enough algebra, you're going to come up with the correct answer. I don't know, the answer in the book may not be like this. It may be like that. And although the answer in the book may be 1 minus root 2 over 2 divided by root 2 over 2, which incidentally is 2 minus root 2 over root 2. And if you check the book, probably it's something of this type. Okay. That takes care of number 40. Let's go to another group of problem. This is number 43. These are very important later on. Some of you will take calculus. These things are going to pop up. It says, write as an algebraic equation in terms of x. So we have sine of 2 tan inverse of x. So what that means is on the right hand side, on this side, no trig stuff. Okay, so here's the way these problems work. Well, I've never done things like this. These are hard, so make sure you know how this works. Okay, so let me call this u. Okay, so we have, let me call this actually theta. How about that? Theta. Okay, so we have theta equal to 2 tan inverse of x. That means tan inverse of x is equal to theta over 2, right? That means tan of, well, let me put it like this. That means that x equal to tan of theta over 2. Okay, so we have this. We want to find, look at what we want to find, sine of theta. Okay? So, well, there are different ways of doing this thing. You can, for example, say here, just look at this. You can say that you have to look at the stuff that we did with these formulas that we had. Why don't I let me write sine of theta equal to 2 sine of theta over 2 cosine of theta over 2. Okay? Good. So if you look at this expression, it tells you what tan of theta over 2 is, but it doesn't tell you what sine of theta over 2 or cosine of theta over 2. This is where drawing that triangle, right triangle, this angle 90 degrees, this is theta over 2, and if you look at that, that's x over 1, so the opposite is x, the adjacent is 1. Just look at this expression, look at this triangle, tangent of theta over 2 is opposite, which is x, divided by 1, which is that expression here. Now from Pythagorean's theorem, this thing will become x squared plus 1, okay? So sine of theta becomes 2 times, well, sine of theta over 2, just look at this triangle. What is the sine of this angle? It is the opposite over the hypotenuse. And what is the cosine of theta? It's adjacent over the hypotenuse. And if you looked at the answer in the book, this is going to look like that. 2x over x squared plus 1 quantity squared, which incidentally will be 2x over x squared plus 1. Therefore, sine of 2 tan inverse of x is what you see over right there. Right there. You have to practice these things. Okay, so let me do the next one. Okay, so next one is going to be 44. 44, tangent of 2 cosine inverse of x. What is it in terms of x algebraically? Okay, so just like before, what I'm going to do, I'm going to call this thing theta. Theta equal to 2 cos inverse of x. That means cos inverse of x is theta over 2. That means cosine of theta over 2 is equal to x. Then I'm going to draw a right triangle. This angle is theta over 2. And if I looked at this as x over 1, the adjacent is x, the hypotenuse is 1. Therefore, that missing side, the opposite side, is 1 minus x squared. So what do we want? We want tangent of theta. This is what we call theta. We want tangent of theta. And we have some information about cosine of theta over 2, etc. So let's look at our formulas that give you theta in terms of half angle. Now it looked like this. There are, let me see if I can. So this is going to be 2 tangent of theta over 2. That's one way of doing it. Divided by 1 minus tangent squared theta. Okay. This is the half angle formula. This is the, well, you can call it half angle, double angle. Oops, double angle formula in terms of tangent. So let's see now. What is the tangent of theta here? Tangent of theta is theta over 2. Just look at this triangle. Tangent of theta over 2 is opposite the root of 1 minus x squared divided by adjacent, which is x. All right. So let's go ahead and plug it in. This is equal to 2 times tangent over 2, which was here, 1 minus x squared over x. And then down below, 1 minus square of this fellow, square of that fellow, 1 minus x squared over x, quantity squared. Let me do some algebra because in all likelihood the answer in the book is not going to be like this, and you want to make sure that you are getting answers in the book divided by x. And down below you have 1 minus x squared divided by x. And you clean it up, and it's going to look like this. 2 square root of 1 minus x squared. And if you do the algebra here, there's a square here. There's a square there. Okay, it's this quantity squared, so that makes this thing x squared. So if you do this, I think I better clean this up then. Okay, so that's going to be in the numerator. I have this. In the denominator, I have. If you take this thing, you get minus 1 over x squared, and this is going to be minus 2x root of 1 minus x squared. There we are. Okay? These problems, you have to use your brain. Okay? Let's do number 45. After 45, I'm going to stop this because I don't want this video segment to become too long. So, Same deal. Sine of 1/2 cos inverse of x. So let me call this thing theta. Theta equal to this thing I call theta. 1/2 of cos inverse of x, which means cos inverse of x is equal to 2 theta, right? Or we have cosine of 2 theta equal to x. There we are. And we want sine of theta. Okay, well, good. We have the formula. This is uh, the double angle formula, or if you want, call it half angle formula. It really doesn't matter, but it looks like this: 1 minus uh, 1 1. Let me see. Which one am I referring to? Let's go back to our right there. So I'm looking at that. I'm looking at the bottom. See half angle formulas. The bottom. Bottom on the left side. You see that? Bottom on the left side. Sine of sine of theta equal to plus or minus square root, etc. So let me write it here for you. I'm using this formula. Sine of u over 2 equal to plus or minus square root of 1 minus 1 minus cosine of u over 2. But except that my the u is, I'm replacing it with 2 theta. So this thing can be written as sine of theta equal to plus or minus square root of 1 minus cosine of 2 theta divided by 2. That's what I have, right? Yeah. So let's see now. Well, first of all, if you look at this expression, we need a plus or minus here. Let me get rid of this. Okay, plus or minus square root 1 minus cosine of 2 theta. Well, cosine of 2 theta, we worked it out. It came out to be x. Right there. See this? Right there. Right there. Okay. Now, divided by 2. The question is, which one of these do we want to pick? Now, we have to look at this thing a little bit carefully. So, when you write this, when you just look at this, when you write this, let me remind you that it means that x or theta, 2 theta, is between, go back to the stuff that you did with cos inverse function. When you write this thing, the angle that it spits out is between pi and 0. When you write cosine inverse equal to something, that something that the calculator spits out is always between 0 and pi. That means the sine of this angle, look, if theta is 2 theta is between pi and 0, okay, that means theta over 2 is between pi over 2 and 0, okay? And what does that mean in terms of sine, S-I-N of it? Well, if you are here, sorry, this is not 2 theta, this is not theta over 2. You divide both sides by 2, you get that. That means S-I-N of S-I-N, right here, S-I-N of theta must be positive. That means do not take the negative sign. In other words, for this particular problem, sine of theta is plus square root of 1 minus x over 2. Okay, now let's do the other one, which is finding cosine of theta, right? No, that's all we wanted. That's all we wanted. That's right. This is it. That's the end of the root. It's the end of the way. So let me write it here. So we have shown that sine of 1/2 cos inverse of x equal to plus square root of 1 minus x over 2. Now I'm going to stop this and do a few more problems that are left in the fourth video segment.